Hi, and welcome to MSc. On today's lesson, we're looking at determining the components of a vector. So the example I have here is a vector that has a size or a magnitude of 55.5, and that's already drawn for us here. This is vector D, and we have an angle 25 degrees north of east. And we remember, although this is pre-drawn for us, that we should draw things with the compass rose in mind, of realizing that we would always have north running up on the page, south would be down, and east should be to the right by convention. We then are going to break this into the two components of which it's made. And we're going to choose components wisely. We're going to choose ones that are one that is along the horizontal axis, and we will choose one that is along the vertical axis. And we choose that in such a way that the angle that they form with each other is a right angle triangle. That allows us to use the primary trig ratios. We're going to name these. This is going to be my x component. We'll call it dx. And the other will be my dy in the y direction. And the positive y runs in the north, and the positive x runs in the east in this example. That doesn't always have to be the case, but generally we want to align our vectors with our positive directions whenever possible. So to determine the equations for these components, we will use an equation where we say, okay, dx is the adjacent side to this angle. Adjacent implies cosine. So we're going to use cosine of the angle, and we're going to use the hypotenuse on the other side. In this case, the hypotenuse is the vector d. Now, technically speaking, we're looking at the absolute value of that because we're not worried about the direction. But we can start to sub in some numbers here. We can say 50.5 and cosine of 25 degrees. Typically, when I'm doing work with components, I would just leave my number like this, and I would use it in that format in the next step of the problem. Typically speaking, this is not going to be a nice whole number or even a simple decimal like 0.5. You can look for that by checking for special angles that would appear here, such as 30 perhaps, or 45 or 60. 25 is not one of those. I would be very tempted to leave that in this form, but if you wanted to switch it to a decimal, or the question required you to do so, then you could calculate that on your calculator, ensuring, of course, that you have set your calculator for degrees and not for radians for this example. And you would get something that looks like this, and that would be meters in the east direction if you're looking for how much of the component represents. We would round this then to 3 significant figures because that is what is provided in the question. So I would say that the x component is 45.8 meters. Likewise, for the dy, this would be d, and it would be sine theta. The derivation for both this and the first equation for dx are contained in a previous video if you're interested in looking at that. And we can again substitute. This is 50.5 sine of 25. And once again, I'd be tempted, if I had to use this in the next step, to simply leave it in that form, because that form is probably nicer to write down repeatedly than the decimal equivalent. And if I have to enter this in my calculator fully, I want to enter the 50.5 sine 25 and not this with having to put repeated 2's on the end. That's what the bar above that means. Again, if I was required to find the length of that component, then I would round to 3 significant figures, and I would write it like this in meters. The x then represents the part of the vector that goes to the east, And so from our start, we would have traveled a distance of 45.8 meters east. And at the end of our vector, we would have traveled a distance 21.3 meters north of our starting position. And that's a calculation of both components of this vector D. I hope you've found this video helpful. Thank you very much for listening, and thank you very much for watching.